A computing paradigm is a conceptual framework or collection of rules that dictate the development, application, and functioning of a computer system. It explains the system's internal data manipulation and transformation procedures, and additionally covers how the system communicates with its surrounding. The imperative, object-oriented, functional, and logically oriented paradigms are a few prevalent paradigms in computing. It is important because it provides a set of principles and concepts that shape how programmers think about and organize code. It offers a different style and approach to organizing and solving programming problems and reducing the complexity of a program and providing a standard approach to common problems. Imperative programming is one of the oldest and the most fundamental programming paradigms. It is characterized by a sequence of explicit command and for the computer to execute, focusing how a program operates rather than what the program should accomplish. This paradigm emphasizes a step-by-step approach where instructions are carried out in a specific order to manipulate the program state. This approach is akin to providing a detailed recipe that outlines each step required to achieve the final result, making it intuitive and straightforward for developers. The benefit of imperative programming are numerous. Its uncomplicated approach makes it simple to understand and apply, particularly for novice. The paradigm efficiency originates from its capacity to accurate control program execution, resulting in optimal performance. Flexibility is another key advantage, as imperative programming may be used in a variety of domains, including system programming, application development, and game creation. Imperative programming remains a core paradigm for a wide range of software development demands, from low-level hardware control to high-level application logic, due to its simple and manageable code structures. To summarize, imperative programming remain a cornerstone of software development due to its clarity, control, and broad application. Its step-by-step methodology and emphasis on how tasks are completed make it suitable for a wide range of undertakings. The evolution of imperative language throughout the decades demonstrate the paradigm versatility and long-term significance. Whether you are constructing large system, developing apps, or beginning to program for the first time, knowing and applying the imperative paradigm lays the groundwork for successful software development. Timeline of imperative paradigm evolution is from 1940s to 1950s. It's the early beginning. It has assembly language, the earliest form of programming language closely tied to a machine code and providing low-level control over hardware. And then we go to 1957, which is Fortran. Fortran is a formula translation developed by IBM. Fortran was one of the first high-level programming language designed for scientific and engineering computation. We move on to 1960s. We have COBOL, which is Common Business-Oriented Language. It is designed for business data processing. COBOL emphasized readability and was widely adopted in business, finance, and administrative system. From 1970s, the rise of C, developed by Dennis Ritchie at Bell Labs. C became the quintessential imperative language due to its efficiency and portability, influencing many subsequent languages. From 1980s to 1990s, the expansion and diversification. It has Pascal, aimed at teaching structured programming. You have ADA, developed by the US Department of Defense, focusing on reliability and maintainability. It has C++, an extension of C that introduced object-oriented features while retaining imperative roots. From 90s to 2000, it's a modern imperative language. We have Java, which still we use now, designed for cross-platform compatibility and widespread use in web application, and Python, which is emphasized readability and simplicity, making it popular for rapid development and diverse application.
Imperative program paradigm focuses on a sequential set of statements meant to immediately alter the state of a program. This paradigm focuses on providing instructions on how to execute tasks by actively changing the state of a program using loops, assignment statements, and conditional structures. The von Neumann architecture, which places a strong emphasis on a central processing unit control, and memory, is very similar to the architecture of the imperative paradigm. The memory holds data and instruction of the program, and variables are used to manipulate the data. The sequential order of executing instruction is controlled by an instruction pointer, and control commands such as conditionals and loops direct the program's execution order. This architecture is appropriate for jobs demanding process manipulation and control because it provides direct control over the execution of the program. Let me explain the characteristics of imperative paradigm. First, state modification. Programs that use imperative programming actively alter variables and data structures values in order to change their state. This indicates that assignment updates and alterations made to variables and other program elements change the program state. The next one is sequential execution. Imperative program follow a set of sequence of instruction and control flow when they are run consecutively. Step by step, statements are carried out one after one. And the last one is control structure. Imperative programming allows developers to carry out particular action based on predetermined conditions by using control structures like loops, for example for and while, and conditional expressions like if-else to manage the flow of execution.
Now I will talk about the strength of imperative paradigm. Firstly, imperative paradigm is easy to read. This paradigm involves writing code in a step-by-step fashion, much like following a set of directions. This readability is beneficial for identifying issues and collaborating with other developers. When the code is written sequentially, it is straightforward to follow the flow of execution, making debugging and code reviews more efficient. Secondly, the imperative approach is relatively easy to learn. The sequential nature of imperative programming aligns with how we naturally think about solving problems. This makes it an excellent choice for beginners who are just starting their programming journey. But following logical steps, new programmers can quickly grasp how to write and understand code. Lastly, the conceptual model of the imperative paradigm is easy to understand. It simplifies problem decomposition into a sequence of instructions, helping new programmers quickly understand the basics of coding. This straightforward approach makes it easier to learn programming concepts and apply them to solve real-world problems. Now let's discuss about the weakness of imperative paradigm. One major weakness is code extensiveness. As problems become more complex, the amount of code needed increases, making it challenging to manage and maintain. This extensive nature can lead to confusion and mistakes. When the code base grows, it becomes harder to follow and understand, which can slow down development and increase the likelihood of errors. Another significant weakness is that imperative code is prone to errors. Because of the close connection between state and execution, changes in the code can easily introduce bugs, especially in large code bases. Managing state changes and ensuring consistency throughout the program becomes difficult. This tight coupling between state and execution can make debugging and maintaining the code a daunting task. Finally, there are challenges in maintenance. System-oriented programming often results in code that is harder to maintain and expand. Modification made to one section of the code can lead to unforeseen consequences in other areas, making it challenging to upkeep and enhances applications. This can block the development of new features and slow down the overall progress of project.
So I will be comparing between imperative paradigm and object-oriented paradigm. So first of all, it's handling complexity. Imperative paradigm uses control structures to manage complexity, while OOP reduces complexity through abstraction, encapsulation, and design principles. Other than that, code organization. Imperative paradigm organizes codes around procedures or functions, whereas OOP organizes code around classes and objects, bundling data with behavior. The third one is code reuse. Imperative paradigm achieves reuse through functions and libraries, while OOP promotes reuse through inheritance, polymorphism, and design patterns. Last but not least, the state management. Imperative paradigm changes state directly through variable assignments, often using global state, while OOP encapsulates state within objects and manages it through control method. Based on my analysis, in C programming, imperative paradigms are predominant, prized for their simplicity and efficiency, especially in system programming and embedded development. While OOP, object-oriented programming, principles can be approximated in C, but the language strength lies in its procedural nature, offering clear and concise solutions without added complexity. Imperative programming in C is favored for its direct control and optimization capabilities, making it the preferred paradigm for many developers in crafting robust and maintainable software systems. Thank you. So basically, the C program calculates the factorial of a non-negative integer using an imperative approach. So the explanation is include header file, which is hashtag includes studio.h, includes the standard input output library, allowing the program to use functions like printf. Factorial function, the factorial bracket function takes an integer n as input. It first checks if n is negative. If so, returns -1 to indicate that the factorial of a negative number is not defined. Otherwise, it initializes a variable result to 1. It iterates from 1 to n, multiplying the result by each integer in the range. After the loop, it returns to the compute factorial value. So the main function declares an integer variable number and initializes it to 5. Call the factorial function with number as an argument and assigns the result to the variable result. Check if the result is -1. If so, it prints a message indicating that the factorial of a negative number is not defined. Otherwise, it prints the factorial of number. Return statement, the main function returns 0 to indicate successful program execution. Then it will output the result of the 5 factorial. Overall, this program demonstrates the imperative approach to compute factorials, handling negative input gracefully, and providing appropriate output message.
In my opinion, the imperative programming paradigm stands out for its clear approach to problem solution and execution. It's emphasized on a clear sequence of commands closely resemble how most hardware interprets instruction, making it an easy choice for many developers. Through much study and research, I discovered that the predictability and clarity of imperative programming are very useful for understanding how software interacts with hardware at the lowest level. This paradigm direct manipulation of program state via variables and implicit control structures enables fine performance tweaking, and which is essential in system programming and real-time application.
The imperative paradigm's educational value cannot be overstated. It serves an excellent introduction to fundamental programming concepts such as loops and conditioning. My in-depth study of programming methodologies highlights that starting with imperative language like Python or C provides a solid foundation for learning more advanced concepts and paradigms. By mastering the basics of imperative programming, developers build essential problem-solving skills that are transferable across various programming languages and domains. This foundational knowledge is crucial because it is key aspects of successful software development.
In my critical review of programming paradigms, I highlighted that imperative approaches adaptability and broad application. It is extremely versatile, enabling a wide range of applications from low-level system software to advanced application development. This versatility guarantees that skills learned in imperative programming are applicable across various technology breakthroughs. Despite the introduction of other paradigms such as functional and declarative programming, the imperative paradigm remains important due to its core concept, which underpin many current programming languages. This continuous relevance highlights its importance in the changing context of software development.
Moreover, the imperative paradigm's emphasis on explicit state manipulation and control flow enhances code readability and maintainability. My deep analysis has shown that this clarity aids in debugging process, making it easier to identify and resolve issues. This characteristic is particularly valuable in large-scale software projects where understanding and maintaining code quality is paramount. The ability to write clear, maintainable code is a significant advantage in collaborative environments and long-term projects, enforcing the imperative paradigm's utility in professional software development. Through comprehensive reading and critical thinking, it is evident that imperative programming paradigm remains a robust and indispensable approach in the world of computing.